Good afternoon, everyone. I'm Sharon Dooley. I'm going to be the moderator uh, for this presentation. I think it's going to be fascinating. It's titled Enable Containers for SQL Server Databases with SUSE Container as a Service Platform. And SUSE has come up with a way to put more initials into that than I have ever seen before. Uh, we have two speakers, Balaji Barmavat, who's from SUSE, and Vin Yu, who is a Microsoft program manager. And I'm looking forward to hearing what they have to say. We thank our sponsors. They're the ones that make it possible for us to send you raffle prizes after each meeting, and we are very grateful to them. We do have new past board members that were elected during the summit: Roberto Fonseca, Laurie Edwards, and Jennifer Moser. And we also want to thank some of the outgoing members for their years of service. SQL Saturday, if you haven't gone to one, they're well worth going to. They're all over the world. They're picking up again now that the holiday season is over. They're free one-day training events, and there's bound to be one within a short distance of you, if not in your own city. And these are some of the upcoming ones that should have been deleted. Uh, we are always looking for new sponsors uh, for who are willing to sponsor events in the community, and for the virtual events like these. And if you have a work for a company that you think might be interested, the contact information is there. We are one of many virtual groups. We're organized by a particular function, database administration, but there are also some that are organized by languages. One that's somewhat different from all the others is the Women in Technology virtual group. It's devoted to increasing the visibility and successes of women in technology. And we have a luncheon every year at the summit. It's amazing how it's grown over the years. And now there are actually more men than women in the luncheon. I urge you to check it out. They do send out a newsletter every month. Twitter handles, etc., etc., etc. I guess that rightmost thing is an Instagram. I don't know what it is, but now our presenters, as I said, are Balaji Barmavat and Vin Yu. Balaji is a public solution architect at SUSE. He's got more than 14 years of IT experience, with 7 years focused on business application solutions, application cloud migration, applications modernization, data, and open source solution. He's focused on technical innovation and product solutions on public clouds. Vin Yu has been a program manager on the SQL Server team at Microsoft for more than 5 years. He works specifically on SQL Server on Linux, containers, and Kubernetes. Recently, Vin has focused on the use of SQL Server and containers for application development, CI/CD, and production use cases. And now I'm going to shut up and turn the meeting over to them and let them do their thing. informed. I've lost Balaji.
No, Sharon,
Right, you're here. Okay, I'm gonna make you a presenter if I can ever get to the.
so thank you, Sharon, for the introduction, and thank you, past community. So my name is Balaji Barmawat, and I'm a cloud architect at SUSE.
And hi, everybody. My name is Vin Yu, and I'm a program manager with the SQL Server team.
Okay, and today we are going to discuss about how containers can be used in database space, basically enabling containers for Microsoft SQL Server on SUSE CaaSP platform. So the agenda is we will just start with what is IT modernization, then we'll talk about containerization, then we'll focus on container as a service platform, and we have two demos are lined up, so we'll show you the demos too, how we can create a container, database container, and how you can deploy it on platform. Okay, so let's take a step back, and we are in a modern world where some of, I guess most of the things are driven by technology, right? And the business, any business if you take to meet their business demands, so that business need to have IT transformation in place. So IT transformation is required to meet changing business demands. And if you see IT transformation, so it has a four sections or pillars, right? So any apps, it should run on infrastructure. So it's IT infrastructure. It doesn't matter whether it's a data center or hosted or a cloud, but underlying is infrastructure. So IT infrastructure is one solid pillar. Then we have application deployment. So how you are going to deploy your applications, right? So the way back when we started IT transformation, we were having physical servers where we just deploy your applications or databases on one single server. Then after a couple of years, virtual machines has arrived, and we have VMs, and we can deploy VMs in a physical servers or bare metal. Then we have containers. We'll talk about. Then moving on to the application architecture. So application architecture is also one of the key pillar how you are going to design your app, right? So in way back we have a monolithic applications. Then n-tier has evolved. Now we are in a age where everything is microservices. Now the last one is the development process, right? So I believe the most of us who are early couple of years back started IT career, we used to have a waterfall method. Then over the time, agile methodologies has evolved. Now we are in DevOps, where team work as together to release something fast. So our focus is application deployment, right? So we'll talk about the application deployment now. So let's take a step back. The step one is server, host server, the physical server. So when we don't have anything, we used to build our application and deploy it on servers. Good. Now over the time when VMs have, then we used to have the VMs in a server, and VMs comes with their own OS, and VMs also based on the databases or based on the apps, it comes their own application libraries or application softwares. Right. So if you see here, I have a VM, and VM has its OS and its configuration data and drivers. It's all are OS related, and it also has the libraries which are required by the apps. Right. Let's say I have an app which needs the libraries, couple of libraries. So my VM has those libraries and also my app. Now I can build this any number of VMs as I need. But every time when I want to run a VM, it has to be on it will has its own OS, and it will also has its own programming libraries. So I can build a VM with my own, and it has my OS and all my libraries for my application. So I can build any number of VMs. Now, what is the disadvantage of the VM is the VM is almost all like it has the complete set of the OS and the libraries which are required for your app or databases. Now, what is the container is the container is a very small or lightweight package which has all the required libraries for your application, and it will directly run on the host OS, directly run on the kernel. So if you see here, we have I extracted my apps which are in VM into the containers, and these all are the different apps or different containers, and I can deploy these containers in a host. So this is one container, this is another container. So every container is a single packaged, and let's say if it is a database container, it will have the SQL Server library information, and if it is app, then app will have its own library details. So it's a single packaged single package which has your app and supported libraries. And the advantage is it's a single. You can deploy it on any OS because it directly runs on kernel. So the advantage of containers, how they do help in IT transformation is, so the first thing is you can speed up your application development and delivery. So since container supports the microservices, where you can build a very small microservices which has some business function or business logic in it, and you can develop it and you can deploy it. So when we are developing and deploying, that microservice has all the dependencies it required to run it in any machine. So thereby we can accelerate the application development and delivery. So you can just develop a container, you can deploy it on any machine. If it works on your machine, it will work on any machine. And the other advantage is you can build the apps very fast, because now we are in a microservices era where everything is a service. You can build the services in a lightweight mode and compose it way, and you can deploy it. You don't have to build a big bang application over the time, and by the time we build it, oh, something has been changed from the business, something has changed the business context, then rebuild it. You don't have to do it. You can divide into the mini services, and you can deploy fast. If any changes happens, those services are getting impacted, not entire application. And thereby we can easily transform the applications. So any application, if it is a big monolithic application, we can divide it into the smaller chunk, and we can further divide if based on the business context and logic, and we can easily build and create services. Okay, so as I said, so application development and delivery, right? So it works on my machine because it's a container. It will work on somebody's machines tomorrow, and it will work on QA. So in other words, if a database container works on in my machine, it will definitely work on the other machines. We don't have any issues saying that, yeah, it works on this machine, it works on this server, it works on this environment. So containers has a powerful a way of making things to work. And if you just think back how the enterprise is adopting the containers workloads in the production, so almost all 27% enterprises are running containers in the production, and the rest of them are planning to run within a year.
All right, thanks, Balaji, for explaining a little bit about containers. Now, before we get into SQL Server in SUSE containers, one thing I'd like to just bring up again is that I just a little over a year and a half ago, SQL Server was only on Windows, and now we're on SQL Server on Linux, and this includes SUSE Enterprise Linux. And actually, one question that we always get is, hey, is this the same engine? Does feature A work? Does feature B work? And while we have this online, I still get this question all the time. You know, actually, so with SQL Server on SLES, it's the same SQL Server engine. And what I mean by that is, you know, features such as temporal tables, dynamic data masking, and you can see on this list and so much more that I can't even fit on this slide deck is available. So by and large, anything that can be configurable with the T-SQL Service area, it's going to work. It's going to work the same way as it does on Windows, as it does on SUSE Enterprise Linux, right? So, you know, over the last year and a half, I have been working with customers who have adopted, you know, SQL Server in a containerized manner. And a lot of these customers are adopting SQL Server in containers for many different purposes, from local dev test, which Balaji has mentioned in one of the slides before, to also doing automation and DevOps pipelines, and then finally, you know, deploying this with container orchestrators such as Kubernetes, and perhaps later shown in SUSE CaaSP by Balaji as well. And here's some of the reasons why some of the customers are actually coming to us. And the first thing is it's isolated. So every SQL Server container is in its own environment, which means it doesn't share in its environment with another application, which can hinder its performance or hinder its environment, causing problems. It's consistent. So every single time a SQL Server container starts up, it's started in the manner in which the Docker file specifies it to, right? And then when you take it down and spin it back up, it's always running in that same manner. Third one's portable. So as Balaji mentioned before, in my dev environment, if I'm working with a SQL Server container, I could bring it into my testing and QA and dev environment, and I could bring it onto across different machines, whether it's on-prem to the cloud, it's going to work the same. Then next two is ease of use and ease of starting and stopping. So we're going to show you this shortly in the demo in a bit. But doing an installation and setup and starting a SQL Server instance in a container is really simple. And last but not least, there is no installation. You know, all that's required for a SQL Server to start up is just to download the container or build your own and start it up. So now I'm going to switch over machines. Just give me a moment here, and we are going to run through some demos. All right, it's going to give it a moment to start up. Okay, hopefully everyone can see my screen. So, you know, SQL Server container images based on SUSE are not yet available on Docker Hub or any other repo, the public repo that's available for acquisition yet. So I'm going to show you how you can build your own. So first I'm going to show you my Docker file, and a Docker file is just a definition of what my container image is and how it should start up. Right, so the first line, so the first two lines here are actually comments, but that first real line here, you can see that it says from SUSE SLES 12 SP2. And what this is it's saying what is the base OS on which our container is building on, or whatever container that we're building on before can go here as well. The next two lines is to copy the repositories and services into the container so that our the package manager within the container can access some additional files. And we need to do this because SQL Server requires some of the dependencies which is offered by SLES. Right. Next we run is a zipper refresh, and this is going to refresh the package manager so that it's updated with the latest repos. And then we are going to add the Microsoft SQL Server repository so that the package manager knows where to get the SQL Server package. Then we import the keys to ensure that we're verifying the package that we are downloading what we're supposed to download. Then we're going to do the package manager install SQL Server, and this part is the part where the package manager is going to extract SQL Server and lay down the bits. Right. Next, we're going to copy an msqlconf file into this directory, and what this does is the msqlconf allows you to it has a list of settings which allows you to configure SQL Server on startup. And this could be things like, for example, SQL Server agent, where SQL Server agent by default doesn't get turned on. However, I could put a line to say inside this msqlconf file to say, hey, turn msql agent to on. Then I'm going to expose 1433 within the container, which allows for SQL Server to listen to on this port. And last but not least, I'm going to start the SQL Server process. Okay, so now that I've shown you this, let's actually go ahead and build this. So to build this, to use this Docker file, I would actually do a Docker build. And what I'm going to tag this as MSQL SLES. Right, and you can see that all the steps here, as mentioned, that I mentioned before, it is the Docker build command is actually going through each step, specifying what it's trying to run and running it. Right, now you can also notice that this is actually really fast, and that's because I've built this before. You can see that on each row it says using cache. Now normally this would take 2 to 5 minutes to update the repos, download the bits, and installing it depending on your network and the speed. Right, so also notice before I showed you the Docker file. This is also available on our GitHub. I posted earlier this week. I'll share that link after this presentation is completed. So with that said, now let's take a look at our images. So I built this. So I do Docker image ls. You can look at the very top. I have an image that was built 48 seconds ago, right? And this is the MSQL SLES container. So let's go ahead and run this container. And I want to show you. So I could do this with the Docker run. And this is, so I would run Docker run, and this is to start up the container. And it says accept EULA equals true. So this is accepting the EULA and in which to run the SQL Server bits. Next, I'm going to set an SA password. Then I want to have the port listen into the container at 1433. And on my host, I'm going to listen to on 1433 as well. I'm going to name the container SQL2. And the image I'm going to run is MSQL SLES. And you can notice that that command finished really quick. So let's take a look at this process. And we can see here, there's a little bit of wraparound on my screen because I made the font a little bigger for the purpose of the presentation. But you can see that this image was created 36 seconds ago. And the container has been up for 35 seconds. Now that we have this running, let's actually connect to it. So here I have Azure Data Studio. I'm going to connect to this image. So this is the port in which I'm connected to. I'm going to press connect. And Azure Data Studio is going to make some initial queries to the SQL Server instance and to the SQL Server instance to connect to this. And you can see on the very right here, it says Linux SUSE SP12. You can also notice that the computer name, I am indeed connecting this container because if you look at the computer name of this container, it says F99 and ends in FF2. This is the same container ID on my machine, right? So with that, I've shown you how to build your own SQL Server on SLES container, and this is also available on GitHub. We'll share that at the end of the presentation, so stay tuned. And now I want to just switch back to Balaji, where he's going to talk a little bit about how you could take containers such as the one we just built and put it onto SUSE CaaS.
Yeah, thanks, Vin.
So give me one moment.
So you have seen now how you can build a container, right? Now, just we are going to talk why we need as a container as a service platform, right? So let's say if you don't have a service platform, so building container stack from the ground is not for everyone. So most of the enterprise, they can't do it because it needs lots of time and effort and maintenance and everything, right? So enterprise embraces on the ready to go platforms or services so that they can easily adapt and they can start working on it. The second thing is the total cost of ownership, right? So every time when we want to invest on something, so we need to also see what is the TCO, right? And let's say if you want to do it by your own, building a platform to support the containers, it is going to take time and other things as well. And in some organizations, they say, okay, so we will have the container engine and we'll try to build management on top of it. But having the container engine is not sufficient. So on top of it, you have to do the orchestration and you need to make sure that you manage all the things in a better way. So having the container engine is not sufficient. So containers for building from the scratch and having the container engine is not sufficient, because it's all takes time to build the things. So what we did is we introduced SUSE Container as a Service platform. So what is the beauty of this platform is it is a container management solutions that enables IT and DevOps, and including the database professionals, to more easily deploy, manage, and scale container-based applications and services. So, okay, what it means? It means is if you have a container, any sort of the container, let's take now, Winas build a container, you can pick up the container and you can deploy it on the platform. And so what the platform give you is you can manage the containers in a very efficient way. And let's say if you want to scale it, then the scaling is very easy. And our CaaSP platform has the Kubernetes support, inbuilt Kubernetes support. So that is the greatest advantage, where you can easily orchestrate all the containers. And not only that, so we also have a OS. It's called SUSE Microservices OS. It is the packages or libraries which are tuned for containers and microservices. And we also have an efficient container management. You can manage the container engine. You can manage your image register very nice. You can connect you can get your Docker images into our platform. So you can do all those things. And what is the benefit we are going to get? So the benefit is this. The first benefit is we can achieve faster time to value. So now you know how to build this container. Now you know what is the container platform can do. So you can do the things faster. Then you can. The other thing is simplifying the management of your container platform. So what does it mean? Let's say you want to deploy. You have deployed a database container. You want to scale it, and they scale it for 1,000 nodes. Okay, let's scale it for another 1,000 nodes. Right, very best example, right? During Thanksgiving, all the enterprise apps are connected to the underlying databases, and during that time frame, apps need the scaling. So the way they scale is you have those apps are in containers, and you can just scale the containers by using the platform in a few clicks. So the platform intelligently manages and decides where and how it is going to deploy the pods or containers. And eventually, so you get ROI on your investment. You have a faster way to build it, and we have a platform which can support the pace of your development and your deployment and your scale, and as well as your management of platform. So what I'm going to do is I'm going to run a small demo, and I'll just walk through the demo. Okay, so we have fully support with Kubernetes. So we are certified with Kubernetes, and our platform has a flexibility to orchestrate certain things based on the Kubernetes. And we use so in this example, I'm going to create a simple pod which has a container created by Win. I have created a similar my own container on SUSE Linux /12. So I'm going to take the database containers, and I'm going to deploy it, and I'm going to show you how we can connect it. So basically, I'm creating a new namespace. So what I'm going to do next step is I'm going to have all my configuration in YAML file, and I'm going to create and I'm going to deploy that. And I will show you the YAML file in a minute. Okay, so this is my YAML file. So this is one of the image, and we have the image now. We have not yet have our official image in Docker, but we'll get the image there. So this is my YAML file, which tells what is my app version, what are my specs, where is my image, and what are my port which I'm going to expose, and certain values on the database username and passwords. So the other thing I want to talk about here is the platform, right? The SUSE platform has the benefit of how you can manage the containers in an efficient way. So one of the efficient way is we have the load balancer in place. And if you see here, so we have a inbuilt load balancer, and you can mention which port it is, so that the applications which are connecting, they can just connect to the load balancer. Okay, so you can see here the container is running on the platform, one of the node, and this is the IP load balancer IP. So I'm going to just connect to the container. I'm just running a simple script. Yep, and I'm going to connect it from external machine. So the IP we are going to inputting here is load balancer IP. We are just running a simple query to check. We have successfully established the connection, and we're getting the result back. So far what we did was we just took the container from Docker, and we just deployed through the kubectl in one of the nodes, and we just accessed that container outside the platform. Right. So we have our CaaSP platform image is available in Azure Marketplace, and it is the lower version. We have a newer version image we are working on to keep it in Azure Marketplace. And we also, very soon you will see that SUSE supported SQL Server on SUSE Linux Docker image in Docker Marketplace. And we also have 100% discount if you are using SUSE Linux Enterprise Server, and you'll get 1 year free patches and maintenance. And Microsoft has 30% discount on SQL Server 2017. And we are committed to have a couple of webinars with PaaS group. So we already completed one last month, that is SQL Server on Linux as a modern data platform. And next month we are going to have a webinar on architecting high availability database platform with SQL Server on Linux with SQL. So look for the invites. So we are done for this presentation. So if you have any questions, we're happy to answer.
Okay. We've got some, and I think you're, where are my questions? Your next talk is going to answer one of them. But the first question is, how do containers work if the host operating system is Windows Server 2016?
Yeah, and I can take that. So the Windows Server 2016 has some initial container support. However, it will not run the any Linux containers. It will only run Windows-based containers. You'll have to check on the Windows Server website on its support. However, I do know that there is some native Linux container support that's being built onto Windows Server as well.
Okay. Can you please explain the benefits of using containers for production SQL Server databases? And how does disaster recovery, log shipping, replication, always-on availability groups work using containers?
Awesome. So this is a really big question, and in terms of production use cases, really for us it's about building choice, right? And what we've seen in a lot of companies is they are slowly starting to build a database as a service platform or something similar, where in their own companies you can easily serve a SQL instance. All developers in a lot of different organizations are just looking to build they just need access to a SQL Server instance. They don't really care about how it's built, and they don't want to deal with the deployment of it and then across different environments. And this becomes very cumbersome as well, right? So in terms of production, it is in a company environment. That's that's some of the benefits there. And to your second question on how disaster recovery, such as log shipping works today as is. It uses agent to help do that. Replication, that's actually coming in to SQL Server on Linux for 2019. So that actually works in containers as well. In fact, if you look at our SQL Server samples, you'll find one of those samples of using replication amongst two containers. And how do always-on availability groups work? How this works best is inside a Kubernetes environment, and we've been working on a SQL Server operator, which is currently still only available on Ubuntu at the moment, or just native Kubernetes itself. But this is going to allow you to automatically spin up 3 containers joined through an AG group. So there is more work to be done in this area, but all those things that you mentioned, those are already in progress or have completed.
And I think this is a related question, and you've probably already answered it, but it does always-on work with a container?
Yes, so the answer is yes, but you wouldn't want to set it up yourself. There's some challenges there if you're trying to configure it, mainly due to the fact that there's networking through a container that you have to work through. We are working on as mentioned earlier, a SQL Server operator, which will automatically create an AG group for you with 3 containers spun up. And I actually I just want to take a moment here. To the folks in the audience, I did mention I'd share the Docker file to the SLES image, and I just posted it in the chat, so you'll see this GitHub link to both the Docker files, one for SUSE and on OpenSUSE, and the other one on SLES. So I made one for both.
Okay, could you also send them to me, because I can post them with the I could post it to our web page.
Most definitely, most definitely. I'll share it. I'll share it with you as well.
Okay, great, thanks. Is SSIS supported in containers?
So SSIS does work in, it is on Linux. However, we do not have a container image built by Microsoft yet. That said, this is something that we're looking at, and you could build your own SSIS container with the SSIS package with a similar Docker file.
Okay, I think that seems to be our list of questions. I thank you both very much. You've done really done a great job presenting this new information for us. And I'm looking forward to your next presentation. I think that a lot of the questions today were about basically getting the high availability and the disaster recovery and all. And I think that your next presentation will answer a lot of that. I'm looking to see if any more no questions have come in. So I think that does it. I'm just looking for a place to save the chat log. But I seem to have, I'll just save it in my root directory there. And we'll look forward to the next presentation when you're going to address the whole high availability question. And that's going to be February 27th, the end of next month. And thank you all for coming. And thank you, Balaji and Vin, for your presentation. And I think it's a bit early, but I think I'm going to end the meeting and enjoy the rest of your afternoon or your morning or whatever time it is in your particular area. Bye.
Bye. Thank you all. Bye.